In today's lesson, we are going to begin learning about something called a radian. So far, we have learned about degrees to measure angles, and we have also talked about degrees, minutes, seconds. A radian is another unit used to measure angles. Radians are used a lot in calculus, and while they may seem odd to you as you move through math, they will seem much more easy to understand. So first, we're going to go ahead and just define what an actual radian is. Now, if you look at the definition, it says an angle with its vertex at the center of a circle that intercepts an arc on the circle equal in length to the radius of the circle that is a measure of 1 radian. Okay, so basically if we look at this circle, this angle right here is an angle where this angle opens up to a certain amount such that the length of this arc is equal to the radius of a circle. Now, if my circle was smaller, let's say it was tinier like this, well, then the 1 radian would still look the same because to get that amount of distance in this amount of arc to be the same would still open up to be the same measure in degrees. All right, so what do we have to know about radians? We have to know that the whole circle is 2 pi radians, and if no unit is given, then the angle is assumed to be in radians. So up until now, if we wrote 60 and we left out the degree symbol, we kind of all understood that you meant 60 degrees. Well, now we really have to be careful to put that degree symbol in there. What you see here is our full circle with all of the degrees that we are used to seeing in blue and all of their counterparts listed in red. Now, I want to show you a couple things about them. First of all, we know that the whole circle is equal to 200 or 2 pi radians and equal to 360 degrees. We can take any angle measure that we are given and think of it in terms of a proportion of 2 pi radians to 360 degrees equals a certain number of radians out of degrees. So if you ever forget some of the rules and the tricks I'm going to teach you, you can always fall back on this conversion factor, just like how we know that there are 12 inches in a foot, and so forth. Okay, so let's first make some observations about what we see here. We see that for every angle that we have in quadrant 1, all of these angles have our numerator equal to 1. If we look over here in quadrant 2, all of these angles, the numerator is 1 unit less than our denominator. If we come over here in quadrant 3, all of these guys, the numerator is 1 unit more than our denominator. And then if we come over here in quadrant 4, these angles, you might be trying to figure out the pattern there. Well, at this point, we are almost to be in a full circle, and that full circle is 2 pi. So we can think of it in terms of here, all of our numerators are almost double the denominator, but minus 1. So the numerators are 2 times our denominator value minus 1. And those are some little tricks that we can use to remember those key angles that we've already memorized on our unit circle. Okay, the next observation that I want you to make is the denominators. Now, we've talked quite a bit about reference angles. For example, we know that 30 degrees, 150 degrees, 210, and 330 all have a reference angle of 30. Well, if you look at their corresponding fractions in radians, you'll notice that they all have denominators of 6. If we look at our 45-degree reference angles, all of our 45-degree reference angles have the same denominator as well, and all of these denominators are equal to 4. Now, normally I would be highlighting this, but there's no highlighter and explain everything. And then lastly, if we look at our 60-degree reference angles, our 60, our 120, 240, and 300, we'll see here that all of these denominators are equal to 3. So we can use some of these tricks to kind of help us get used to an angle in radians and think of it in terms of an angle in degrees that we're used to. And just like we did last chapter, The more we work with radians, the more we'll become comfortable with them and just start thinking in radians all the time. The last angle that I want to point out is everything on our quadrantals are either going to be a full pi, so like we'll have 0 pi, or they'll be half of a pi. Pi halves and 3 pi halves. Alright, this screen looks like a big mess. Let's take a look at what else we can do with our radians. Converting back and forth, we're going to use that conversion factor of 2 pi goes with 360 degrees. Now we can reduce that to be pi matches with 180 degrees. So you'll see these two different conversion factors. Basically, it's just a matter of what do I want to end with. If I want to take an answer in degrees and turn it into radians, then I need to have the 180 degrees on the denominator so that when I'm all said and done, my answer will be in terms of radians. If I want to be able to finish with a degrees answer, then I need to have my pi on the denominator so that my radians units will cancel off. Alright, so this next step, we're going to convert these without a calculator. So if we have 160 degrees and we want to turn this into radians, we're going to start with the 160 on top. And then when I write my unit conversion, since I have degrees on top, I need to write 180 degrees in the denominator, and then I will put the pi in the numerator. So now I have my conversion factor ready, and I'm ready to go ahead and simplify. First things first, we can take a 0 off each of them, divide them both by 10. Then I can take 16 into 18 and reduce that to 8/9. So my answer is 8 pi ninths. Now mathematically, if we think about this, we should know that pi equals 180 degrees. And 8/9 pi is a little bit short of a full pi, and 160 degrees is a little short of a full semicircle, 180 degrees. So you can use some of those, clues and just general idea about the circle to help make sure your answers seem reasonable. Alright, now when I convert 40 degrees, some things I want to think about here are that 40 degrees isn't even equal to half of a pi. So my answer better be close to a fourth of a pi, rather, for my answer. Alright, so let's go ahead and do our conversion. 40 degrees times pi over 180. Again, we want the degrees in the denominator. Oops, one too many zeros. And then we're going to go ahead and simplify. We can take a 0 off each of them, and then 4/18 reduces to be 2/9. So 2 pi ninths. Alright, now when we're going the other way from radians into degrees, same concept, except now I want to write my conversion factor flipped around. Again, it's all about what do I want to finish with. Each of these pi's will cancel off. I can reduce the 9 into 180, and I'll get 20, and then 20 times 5 gives me 100 degrees. Now, not every angle that is in radians will have a pi. Many of them will. However, sometimes our answers are not exact, and then the pi will be multiplied through, and we will see a decimal. Alright, if we finish this last one, 3 pi 20ths radians, I want to turn that into degrees. We can go ahead, cancel off the pi's. We can reduce this by 9 into 9, and then we get 27 degrees. This last section is essentially the same thing that we've been doing with our unit circle quizzes. The only difference is that my angle measure is given in radians. Now, many students prefer to take the radians and mathematically turn them into degrees and then answer the question. I'm really going to encourage you to not do that. If you learn to think about these problems in terms of radians, it will make every single computation that you do quicker. So here's how I would think about that. First of all, we know that these are all in first quadrant. And the reason why we know that they are all in first quadrant is because all of the numerators are equal to 1. Alright, so now if we envision our first quadrant, we had those 3 key angles, which we're comfortable thinking of as 30, 45, and 60. Now in radians, these are going to be pi sixths, pi fourths, and pi thirds. And then on the axes, we have 0 and pi halves. So now when I see this first question is asking me to do cosine of pi thirds, I know that I'm really talking about cosine of 60. And by now we should know that cosine of 60 is 1/2. when I see cotangent of pi 6, I should be able to know, okay, well, pi 6 is right over here. And at pi 6, my cotangent ratio is going to be equal to root 3. So these types of questions, there is nothing new here, except we have that added step of having to first find the corresponding angle in degrees. All right, I want you to pause the video and fill out these answers, and then unpause it and check to see how you did. All right, with all of these, you should be comfortable with either first converting the angles into degrees and then answering the question, or remembering those denominator tricks that I explained at the start of the video. The only one that might have thrown you for a loop should be this last one. And when we think about this, a negative angle goes backwards. So just how far backwards am I going? Well, pi halves is a quarter of my circle. So going backwards, pi halves puts me right here. We can also think about this in terms of making a coterminal angle, which means adding a full circle, which would be 3 pi halves. And if we think about it in that way, we still end up at the same spot at 270 degrees. And the cosine of 270 is equal to 0. All right, that's all for today. Have at it with your Math Excel.